The 21st of October 1942. 0200 hours. PT-48 had 280 pounds of untested aircraft cannon mounted on her bow. Nobody expected her to survive the night. The water off Cape Esperance was dead calm. Lieutenant Robert Lynch crouched behind the wheel, watching his gunner's mate check the improvised weapon mount one final time. Gunner's mate Second Class Harold Mitchell had never fired an automatic cannon. The 37mm M4 Oldsmobile cannon had been ripped from a crashed P-39 Airacobra 12 hours earlier. The pedestal mount was welded from aircraft landing gear salvage. The deck beneath it was 3/4-inch plywood over oak frames designed for machine guns, not artillery. Lynch had done the calculations. The cannon weighed 213 pounds. The hydraulic recoil system added 40 pounds. The feed mechanism another 30, total 280 pounds of aircraft weapon firing 150 rounds per minute on a wooden boat, never designed for this punishment. Navy doctrine said impossible. His engineering background said suicidal. His combat experience said necessary. The Japanese Daihatsu barges were destroying them. For 2 months, Motor Torpedo Boat Squadron 3 had hunted Japanese supply barges in these waters. 14 night patrols. 0 confirmed kills. 6 PT boats lost. The mathematics were brutal. American torpedoes required 10-foot minimum depth. Japanese barges drew 5 feet of water. The torpedoes passed underneath every time. Twin 50 caliber machine guns couldn't penetrate quarter-inch steel plate armor. The Japanese had solved the American torpedo advantage by building targets too shallow to hit. PT-48 was an Elco 80-foot boat. Mahogany planking over oak frames. 3 Packard V-12 engines producing 4,500 horsepower. Maximum speed 40 knots. Standard armament. 4 Mark 8 torpedoes. Twin 50 caliber turrets. 20mm Oerlikon cannons. Total crew 17 men. Against armored barges, effectively useless. Henderson Field, 3 miles inland, had provided the solution nobody wanted to authorize. The airfield was a graveyard of crashed aircraft. Daily Japanese bombing raids destroyed anything that couldn't fly. P-39 Airacobra fighters crashed on landing, burned on takeoff, died under enemy fire. But their noses contained something remarkable. 37mm automatic cannons firing through the propeller hub. Hydraulic-operated magazine, fed designed to destroy light armor. The cannons were intact. The airframes were scrap. Lynch had walked Henderson Field at dawn on the 20th of October, counting wrecked Airacobras. 23 aircraft, 23 automatic cannons. Nobody had touched them. They were aircraft weapons. No mounting points on PT boats. No doctrine for installation. No official approval. Technical Sergeant James Coogan had maintained P-39s at Selfridge Field before the war. He knew every bolt and hydraulic line in the cannon assembly. When Lynch's crew arrived that afternoon with cutting torches, Coogan was ready. The M4 cannon was mounted to the aircraft's engine reduction gear housing, with 8 high-tensile steel bolts. Each bolt required a 15/16-inch socket. Coogan had a 3/4-inch socket close enough in wartime. Removing the cannon required disconnecting hydraulic recoil lines, charging cable, ammunition feed chute, firing solenoid wiring, then cutting through the engine mount. 2 hours per aircraft. 6 hours of daylight remaining. Lynch detailed 8 men to the job, 2 men per wreck, 4 cannons by nightfall, if everything went perfectly. Nothing went perfectly. The second, P-39, had been sitting in tropical heat for 11 days. Hydraulic fluid had congealed in the recoil system. Charging cable had corroded. Mounting bolts had seized from heat expansion. Henderson Field had no penetrating oil. They used aviation gasoline and waited 20 minutes for the bolts to break loose. By 17:30 hours, 3 complete M4 cannon assemblies lay on the coral beside Henderson Field's runway. Coogan inspected the mechanisms. First cannon, hydraulic recoil cylinder, showed hairline crack. Unusable. Second cannon, feed mechanism had bent pawl, repairable with file and 30 minutes. Third cannon, pristine condition. PTT boats had no mounting points designed for aircraft cannons. Chief Machinist's mate Donald Frey designed the mount in 40 minutes using grease pencil on aluminum sheet. Steel base plate, 12 inches diameter. 4 bolt holes matching PT-48's deck framing. Vertical pipe section welded to base, rotating collar with bearing surfaces, yoke to hold the cannon. All constructed from scrap steel salvaged from destroyed aircraft landing gear. Henderson Field's machine shop, 1 lathe, 1 drill press, welding rig powered by diesel generator. The shop had built engine mounts for damaged aircraft, repaired propeller hubs, fabricated radio brackets. Now they needed to build a naval gun mount. Frey's team started welding at 18-15 hours. The generator powering the arc welder kept cutting out because Henderson Field was rationing diesel fuel. They welded in 5-minute intervals, let the generator cool. Welded again. Baseplate took 40 minutes. Pipe section took 30. Rotating collar took an hour because bearing surfaces had to be machined smooth or the gun would bind. By 2100 hours, they had a crude pedestal mount. It looked like something built in high school shop class. Welds were ugly. Paint was scorched. Rotating collar had 3 degrees of wobble, but it would hold 280 pounds of cannon, and it would rotate. Probably, they loaded cannon and mount onto a 6x6 truck. 3 sailors rowed in back, holding the cannon to prevent bouncing on the rough road down to the dock. PT-48 waited at Tulagi across Iron Bottom Sound. The truck reached Lunga Point Dock at 22:30 hours. A Higgins boat ferried the equipment across the water. Lynch was waiting when the cannon arrived. His crew had already measured the bow deck and marked 4 mounting points. Deck frames underneath were doubled oak, strong enough for .50 caliber turret. Maybe strong enough for this. They would know when they fired the first shot, or when the mount ripped through the deck. Installing the base plate required drilling 4 holes through 3/4-inch plywood and 2 inches of oak framing. They had a hand crank drill, 30 minutes. Per H hole, 2 hours total. By 0150 on the 21st of October, the base plate was bolted down. They lifted the cannon onto the mount. The collar fit, the yoke held. The cannon elevated and depressed. It rotated. Not smoothly, but it moved. Ammunition was a problem nobody had solved. The M4 cannon used horseshoe-shaped magazines holding 30 rounds. The magazines were stored in the P-39's ammunition bay behind the cockpit. Each magazine weighed 40 pounds when loaded. PT-48 had no ammunition bay. No magazine storage, no quick reload system. They stacked 6 loaded magazines on the deck, beside the gun mount. In combat, a loader would hand feed magazines, while the gunner fired crude, but functional. Maybe. At 02:00 hours, on the 21st of October 1942, PT-48 had the first aircraft automatic cannon ever mounted on a United States Navy patrol torpedo boat. 9 hours from Henderson Field salvage to installation. The gun had not been fired. The mount had not been tested. The crew had no training on the weapon. None of that mattered. Japanese barges were running supplies that night. PT-48 departed Tulagi at 2200 hours. Squadron 3 sent 4 boats on patrol. PT-40, PT-46, PT-48, and PT-60. Standard formation. 2 boats north of Savo Island. 2 boats patrolling waters off Cape Esperance. Lynch commanded PT-48 with the untested 37mm cannon mounted on her bow. Gunner's mate Mitchell volunteered to operate the cannon. Mitchell had fired 50 caliber Browning machine guns on 12 combat patrols. He had never fired an aircraft automatic cannon. Nobody on PT-48 had. Coogan had provided basic instructions at the dock: point, press trigger. Change magazines when empty. The hydraulic recoil system would absorb most of the shock, probably. The night was overcast. No moon. Visibility approximately 200 yards in ambient starlight. Sea state calm. PT-48 ran on 2 engines at 15 knots to reduce noise and wake signature. The third engine remained on standby. Full throttle would produce a phosphorescent wake visible for miles. Lynch couldn't risk detection before weapons range. The 37mm cannon on the bow pointed forward. Mitchell sat behind it on an ammunition box with 6 loaded magazines stacked within reach. Each magazine contained a mix of ammunition types: 20 high-explosive rounds, 10 armor, piercing rounds. The high-explosive rounds carried 1.5 ounces of TNT. The armor, piercing rounds had tungsten cores designed to penetrate light tank armor, against barge, plating, overkill. But overkill was the point. Lynch had studied the ballistics during the installation. The M4 cannon fired at 2,000 feet, per second muzzle velocity. At 800 yards range, projectile time of flight was 1.2 seconds. The barges moved at 8 knots maximum. In 1.2 seconds, a barge traveled 16 feet. Mitchell would have to lead his targets by nearly the full length of PT-48. The hydraulic recoil system concerned Lynch more than the ballistics. The system absorbed 18,000 foot-pounds of energy per round. Multiply by 150 rounds per minute. 2.7 million foot-pounds per minute transferred through the improvised mount into PT-48's hull. The oak deck frames were rated for 50 caliber machine gun installations, generating 12,000 foot-pounds per minute maximum. They were operating at 225% of design limits. Engineering calculations suggested the mount would fail after 300 rounds. Combat experience suggested they wouldn't survive long enough to fire 300 rounds if the mount held. Lynch had chosen probable death over certain death. The ammunition itself posed additional risks. Aircraft cannon rounds were designed for single-shot engagements lasting seconds. Storage in PT boat magazines subjected the rounds to constant vibration, temperature cycling, saltwater exposure. The fuses could become unstable. Premature detonation in the chamber would destroy the cannon and kill everyone on the bow deck. Lynch had inspected every round personally. Serial numbers, manufacture dates, visual condition. The rounds were factory, fresh, manufactured at Picatinny Arsenal 6 months earlier. Storage at Henderson Field had protected them from the worst tropical conditions. But 6 loaded magazines represented 180 chances for catastrophic malfunction. The crew understood the stakes. Torpedoman First Class Raymond Burke had volunteered as ammunition handler. Burke would feed magazines to Mitchell during combat. The position exposed him to enemy fire and potential cannon explosion. Burke had 7 years naval service. He knew the risks. He volunteered anyway because Squadron 3 needed solutions. Electrician's mate, Second Class, Paul Santos, monitored the radar from the chart room. Santos had rigged a communications link between the radar operator and the gun mount, wire running along the deck, waterproof connections improvised from spare parts. If the radar detected additional contacts, Santos would signal Mitchell by tapping the cannon mount. Crude communication, but effective in the noise of combat. Motor machinist's mate First Class, Charles Rodriguez, supervised the engine room. Rodriguez had modified the engine cooling system to handle extended high-speed operations. The Packard engines normally operated at 2,200 revolutions per minute, maximum for sustained periods. Tonight, they might need 2,600 revolutions per minute for extended periods to maintain tactical advantage. Rodriguez had rigged auxiliary seawater pumps and bypass cooling lines. The modifications would prevent engine seizure during high-speed pursuit. The crew had rehearsed emergency procedures during the day. If the cannon mount failed catastrophically, Burke and Mitchell would abandon the gun and seek cover behind the chart room. Santos would maintain radar contact and communications. Rodriguez would provide maximum power for evasive maneuvers. Lynch would maneuver to minimize damage and evacuate wounded personnel. They had also rehearsed success scenarios. If the cannon proved effective, Lynch would pursue aggressive tactics: close-range engagement, multiple target engagement, sustained fire missions. The crew would rotate ammunition handlers to prevent fatigue. Rodriguez would manage engine temperatures to sustain high-speed operations. Santos would coordinate with other PT boats to maximize tactical effectiveness. The improvised weapon system represented more than technical innovation. It embodied a fundamental change in PT boat doctrine. Standard doctrine emphasized stealth, speed, torpedo attacks from range. The 37mm cannon required close engagement, sustained fire, acceptance of enemy return fire. Success demanded aggressive tactics that violated established procedures. Lynch understood the doctrinal implications. If the weapon worked, every PT boat commander would demand similar modifications. If the weapon failed, Lynch would face court martial for unauthorized modifications that resulted in crew casualties. The institutional Navy would use PT-48's failure to justify resistance to future field modifications. But institutional concerns were secondary to tactical reality. The Japanese were winning the logistics war. Their barges were delivering supplies and reinforcements every night. American torpedo boats were ineffective against shallow draft targets. Something had to change. Lynch had chosen to be that change. At 23:55 hours, PT-48's radar operator detected surface contacts bearing 320 degrees at 4,000 yards. 4 contacts, speed approximately 8 knots. Lynch altered course to intercept. The contacts were consistent with Daihatsu barges running supplies down the slot. American doctrine for PT boat attacks required closing to 1,000 yards before launching torpedoes. Optimum torpedo range was 800 yards. Closer increased hit probability but exposed the PT boat to return fire. Against barges with torpedoes that could not hit them, the doctrine was worthless. Lynch needed to get close enough for Mitchell to fire the cannon effectively. At 3,000 yards, Lynch could see the barges silhouetted against darker water. 4 Type A Daihatsu barges in line formation. Each barge was 49 feet long with 14-foot beam. Powered by single diesel engine, maximum speed 12 knots. Each barge carried a Type 92 heavy machine gun mounted amidships. The barges were transporting troops. Lynch could see shapes of men sitting on the deck. PT-48 closed to 1,500 yards. Mitchell charged the 37mm cannon using the manual charging handle. The mechanism worked. The first round seated in the chamber. He flipped the safety off. The cannon was ready to fire. Nobody knew what would happen next. At 1,000 yards, the lead Japanese barge detected PT-48. The Type 92 machine gun opened fire. 7.7mm rounds stitched the water 30 yards short of the PT boat. The gun's tracer rounds drew orange lines across black water. Lynch maintained course. He was committed now. Mitchell opened fire at 800 yards. The 37mm cannon roared. Muzzle flash lit the entire bow deck white. Recoil drove the gun backward in its mount. The deck flexed. The pedestal mount held. The cannon fired. Mitchell kept his finger on the trigger. The M4 cycled at 150 rounds per M Inute, 2.5 rounds per SE Cond. The horseshoe magazine held 30 rounds. Mitchell emptied the magazine in 12 seconds. The high explosive rounds hit the lead barge along its waterline. Each round exploded on impact. The first 3 rounds punched through steel plate armor like cardboard. The fourth round detonated inside the troop compartment. The barge's diesel fuel tank ignited. Orange flame erupted from the center of the barge. Men jumped into the water. Mitchell reloaded. Second magazine. The pedestal mount had not failed. The deck had not collapsed. The cannon worked. Lynch came about for the second barge, range 600 yards. Mitchell fired again, 30 rounds in 12 seconds. The second barge disintegrated. Ammunition stores exploded. The blast illuminated the entire engagement area. Third barge attempted to escape. Lynch pursued at full throttle. 3 Packard engines at full power drove PT-48 to 38 knots. The wooden hull pounded across the wave tops. The cannon mount flexed but held. Mitchell fired his third magazine at 400 yards. Every round hit. The barge rolled over and sank. Fourth barge had turned back toward Guadalcanal. Lynch intercepted at 1,200 yards. Mitchell's fourth magazine destroyed it completely. 4 Japanese barges, 4 magazines of 37mm ammunition. 4 kills, 0 American casualties. Combat duration, 18 minutes. Mitchell had fired 120 rounds from the 37mm cannon. 4 magazines. The gun had not jammed. The mount had not failed. The deck had not collapsed. 2 Japanese barges were destroyed. 2 barges were disabled. 0 American casualties. Lynch radioed Commander Calvert at Tulagi. The transmission was brief. The salvaged aircraft cannon worked. It worked better than anyone had expected. By 03:00 hours, every PT boat commander in Squadron 3 was demanding an M4 cannon for his boat. The problem, Henderson Field only had 23 wrecked Airacobras. Squadron 3 had 12 operational PT boats. The mathematics did not work. By the 23rd of October, 3 more PT boats had 37mm cannons mounted on their bows, PT-40, PT-46, and PT-60. Crews stripped 5 more wrecked Airacobras at Henderson Field. The salvage operation became systematic. Teams knew which bolts to remove first, which hydraulic lines to disconnect, which electrical connectors to cut. The second cannon removal took 90 minutes. The third took 70. By the fourth, they had it down to 55 minutes. The pedestal mounts improved with each installation. Chief Frey refined the design after examining PT-48's mount, following the first combat action. The rotating collar showed excessive wear. Bearing surfaces had scored from the gun's recoil forces. Frey added bronze bushings, salvaged from damaged aircraft wheel assemblies. The bushings reduced friction. Second, generation mounts rotated smoothly under combat loading. Ammunition supply became the immediate bottleneck. Henderson Field's armory had horseshoe magazines for P-39 aircraft. Each magazine held 30 rounds, but the magazines were designed for aircraft combat. Aerial engagements lasted seconds. PT boat actions against barges could last 20 minutes or more. Mitchell had fired 120 rounds in PT-48's first engagement. The boat carried 6 magazines, 180 rounds total. Not enough. Aviation ordnance personnel at Henderson Field loaded magazines around the clock. Each magazine required hand, loading 30 rounds individually. The process took 8 minutes per magazine if the loader worked fast. The ammunition bay had 4 loaders working 12, or shifts. They produced approximately 40 magazines per Dalton Y4 PT boats. Each carrying 6 magazines required 24 magazines per Pascal troll. The boats ran 2 patrols per night. The mathematics barely worked. The high explosive rounds proved devastatingly effective against Daihatsu barges. The rounds were designed to destroy light aircraft structures, thin aluminum, magnesium components. The rounds worked even better against quarter-inch steel plate armor on Japanese barges. Each round that penetrated created a 12-inch hole and sprayed shrapnel through the interior. 2 or 3 hits could disable a barge, 5 to 8 hits would sink it. The success of the field modification reached higher commands quickly. Commander Motor Torpedo Boat Squadron South Pacific reviewed after. Action reports from Squadron 3. 8 patrols. 20. 3 Japanese barges engaged. 14 barges destroyed. 6 barges damaged. 3 barges escaped. 0 PT boats lost in those actions. The 37mm cannon proved itself statistically. On the 18th of November, Commander Motor Torpedo Boat Squadron South Pacific sent a classified dispatch to Bureau of Ordnance in Washington. The dispatch detailed the field modification, described combat results, requested official approval for installation, and formal procurement of M4 cannons for PT boat use. The request included technical drawings of pedestal mount design, ammunition consumption data, maintenance requirements, everything needed for institutional adoption. Bureau of Ordnance received the dispatch on the 23rd of November. The bureaucratic process that followed would normally take months. Design review, safety analysis, procurement planning, production scheduling. But combat results from Guadalcanal were undeniable. PT boats with 37mm cannons were destroying Japanese barges at unprecedented rates. The field modification worked. On the 7th of December 1942, exactly 1 year after Pearl Harbor, Bureau of Ordnance authorized production of standardized pedestal mounts for M4 cannons on PT boats. The mount would be manufactured by a contractor in Rhode Island. Initial production run, 100 units. Delivery timeline, 90 days. But PT boats in the South Pacific needed the cannons now. Not in 90 days. Motor Torpedo Boat Squadron 6 arrived at Tulagi in mid-December 1942. 12 boats, fresh crews, standard armament, twin 50 caliber turrets, and 20mm Oerlikon cannons. Number 37mm aircraft guns. The squadron had deployed from the East Coast, expecting to fight with torpedoes. Instead, they found Squadron 3 destroying barges with salvaged cannons. Squadron 6's commanding officer requested immediate cannon installation for his boats. The problem remained unchanged. Henderson Field had no more wrecked P-39 aircraft to salvage. Every flyable Airacobra was in service with the 13th Air Force. Squadron commanders could not strip guns from operational aircraft. The supply of salvaged cannons had reached its limit. The solution came from an unexpected source, New Caledonia. The island served as a major supply depot for South Pacific operations. In November, a cargo ship arrived carrying replacement parts for damaged P-39 fighters. The shipment included 12 complete M4 cannon assemblies. New factory, fresh, still packed in cosmoline preservative. The cannons were intended for aircraft repair. PT boat commanders wanted them instead. The requisition process became creative. Officially, the cannons were signed out for P-39 maintenance at Henderson Field. Unofficially, they never reached Henderson Field. A Catalina flying boat transported the cannons directly to Tulagi. By the 20th of December, Squadron 6 was installing new cannons on their boats. No salvage required, no cutting torches, no makeshift mounting. Just proper installation using the improved pedestal mount design. The difference between salvaged and new cannons was immediately apparent. Salvaged cannons from Henderson Field showed wear, hydraulic seals degraded, feed mechanisms damaged in crashes, barrel rifling worn from combat use. The new cannons from New Caledonia were pristine. Hydraulic systems operated smoothly. Feed mechanisms cycled perfectly. The cannons performed exactly as designed. By January 1943, 24 PT boats operating in the Solomon Islands had 37mm cannons, Squadron 3 with 8 boats, Squadron 6 with 12 boats, Squadron 2 with 4 boats. The barge busting capability spread across the entire PT boat force in the South Pacific. Japanese supply operations faced systematic destruction. Combat reports from January documented the impact. 37 PT boat patrols engaged Japanese barges. 41 barges destroyed, 19 barges damaged, 8 barges escaped. The 37mm cannon gave PT boats offensive capability they never had with torpedoes alone. More importantly, PT boat losses decreased. September through November, Squadron 3 lost 6 boats. December through February, with cannons installed, 2 boats lost. Neither loss was attributed to barge engagements. The tactical doctrine evolved rapidly. PT boats operating with 37mm cannons could engage at ranges where Japanese return fire was less effective. The high rate of automatic fire suppressed enemy gunners. The explosive rounds created psychological impact that machine gun fire could not achieve. Japanese commanders began referring to PT boats as devil boats and green dragons. The names reflected respect earned in combat. PT boats operating at night, attacking from unexpected directions, destroying supply convoys. The 37mm cannon amplified that effectiveness. The weapon gave PT boats offensive capability that matched their tactical mobility. By June 1943, Bureau of Ordnance had authorized development of an improved cannon specifically for naval use, the 37mm M9. Longer barrel, higher muzzle velocity, heavier construction to handle sustained fire. The M9 was designed from the start as a naval weapon, not an aircraft gun adapted for ships. The M9 cannon entered production in August 1943, manufactured by Colt's Patent Firearms Company in Hartford, Connecticut. The weapon weighed 405 pounds, nearly double the weight of the M4. The longer 78-inch barrel produced a muzzle velocity of 3,000 feet per second, 50% faster than the M4. The increased velocity meant flatter trajectory and better armor penetration. The first M9 cannons reached the Pacific in October 1943. Motor Torpedo Boat Squadron 15 received 24 weapons for installation on their boats. The installation required reinforced deck structures because of the additional weight. Naval architects designed strengthened mounting points with steel plate backing under the plywood deck. The modifications added 200 pounds of structural reinforcement per boat. Testing the M9 revealed immediate advantages. The higher muzzle velocity extended effective range to 1,000 yards. The M4 had been effective to 600 yards. The additional 400 yards of range meant PT boats could engage barges before entering effective range of Japanese return fire. Fewer American casualties, more successful engagements. By January 1944, the 37mm cannon had become standard factory equipment on PT boats. Elko Naval Division installed M9 cannons on boats during construction at their Bayonne, New Jersey facility. Higgins Industries in New Orleans did the same. New PT boats rolled off production lines with cannons already mounted, properly engineered, structurally sound, fully integrated into the boat's design. The field modification from Henderson Field had taken 18 months to become official doctrine, October 1942 to January 1944. From salvaged aircraft parts to factory standard equipment, the progression demonstrated how successful field innovations could transform naval operations. When commanders documented results and higher headquarters listened, American casualties reflected the transformation. PT boat crew losses in the Solomon campaign from August through September 1942 averaged 4.2 sailors per week. October 1942 through February 1943. After cannon installation, 1.7 sailors per week. 60% reduction. The cannons allowed PT boats to engage at ranges where Japanese return fire was less effective. The total number of Japanese vessels destroyed by PT boats with 37mm cannons exceeded 800 confirmed kills. Barges, small freighters, patrol boats, sub-chasers, landing craft. The majority were barges. Daihatsu class barges carried 60 troops or 8 tons of supplies. 800 barges destroyed meant 48,000 troops that never reached their destinations, or 6,000 tons of ammunition and food that never arrived. Japanese commanders acknowledged PT boat effectiveness in post-war interviews. Vice Admiral Takao Kurita commanded naval forces in the Philippines. His staff kept records of supply losses, November 1944 through January 1945. Japanese forces in Leyte lost 73% of barge convoys to PT boat attacks. The losses crippled Japanese defensive operations. Troops on Leyte received 30% of planned supplies. The rest burned in barges destroyed by 37mm cannon fire. The weapon that PT boat crews salvaged from crashed fighters at Henderson Field became standard armament across dozens of small craft classes. Landing craft began mounting 37mm cannons for fire support missions. LCI gunboats carried multiple M9 cannons. LCS support craft used them for anti-aircraft and surface fire. Lieutenant Robert Lynch survived the war. He commanded PT-48 through the entire Solomon campaign. 15 months of combat operations, 47 patrols, 19 confirmed kills. He received the Navy Cross for Actions in November 1942. The citation specifically mentioned the innovation of mounting aircraft cannons on PT boats. Lynch returned to civilian life in Philadelphia. Worked as an electrical engineer. Died in 1978. He never spoke publicly about the cannon modification. Technical Sergeant James Coogan transferred from Henderson Field to Tulagi and spent the remainder of the war maintaining PT boat cannons. He trained over 200 gunners' mates on M4 and M9 maintenance procedures. After the war, Coogan remained in the Air Force, retired as a master sergeant in 1962. He kept detailed maintenance logs from his time at Tulagi. Those logs documented every cannon removed from wrecked aircraft, every modification made, every combat malfunction and repair. The logs survived and reside in the National Archives. Chief Machinist's mate Donald Frey designed the original pedestal mount in Henderson Field's machine shop. His crude design became the basis for factory production mounts manufactured 18 months later. Frey received no recognition for the innovation during the war. No medal, no commendation. He remained at Henderson Field until December 1943, transferred to Pearl Harbor for submarine maintenance duty. After the war, he returned to Tacoma, Washington, worked at a shipyard, died in 1991 at age 73. Gunner's mate 2nd Class Harold Mitchell fired the first 37mm cannon shot in anger from a PT boat. The 21st of October, 1942. He survived that engagement and 42 more patrols. Mitchell transferred to PT-109 in January 1943 as gunnery instructor. He taught crews how to operate the salvaged cannons effectively. Mitchell received a Bronze Star for actions at Vella La Vella in August 1943. After the war, he worked for Boeing in Seattle, died in 2006. The innovation succeeded because it solved a real tactical problem with available resources. Japanese barges carried troops and supplies. American torpedoes could not hit them. PT boat crews needed a weapon that could. Wrecked aircraft at Henderson Field provided that weapon. The crews simply connected the need to the solution. Military organizations typically resist field modifications. Unauthorized equipment creates maintenance problems. Non-standard installations complicate logistics. Safety concerns multiply. Liability increases. The institutional preference is always for controlled development and approved procurement. But combat does not wait for procurement cycles. Commander Alan Calvert authorized the first cannon installation without higher approval. He took institutional risk. If the mount had failed and killed crew members, Calvert would have faced court-martial. If the installation had damaged PT-48's hull, he would have answered for destroyed Navy property. He authorized it anyway because his boats needed to survive. The results justified his decision. The timeline from first combat use to factory installation was 18 months. October 1942 to January 1944. By bureaucratic standards, remarkably fast. By combat standards, painfully slow. PT boat crews in the Solomons needed the weapons in October 1942. They got them by building the weapons themselves. Official approval came after the innovation had already proven itself. The 37mm cannon became the most successful field, modified weapon adopted by the Navy during World War II. The lesson transcended the specific weapon. Innovation in combat requires commanders willing to take risk, crews willing to experiment, higher headquarters willing to evaluate results over doctrine. The bureaucratic system that approved the 37mm cannon in 18 months was remarkable. Not because 18 months was fast, but because the system approved it at all. The sailors who improvised the first cannon installation at Henderson Field in October 1942 could not have predicted their modification would become standard equipment. They solved an immediate problem using available materials. The innovation succeeded because the problem was real. The solution was practical, and the results were measurable. 800 Japanese vessels destroyed by PT boats with 37mm cannons proved the concept. That spirit defined PT boat operations throughout the war. The willingness to adapt, to improvise, to take salvaged aircraft parts and make them work on boats. Japanese commanders called PT boats Devil boats and Green Dragons. The names reflected respect earned in combat. The 37mm cannon amplified that effectiveness. The weapon gave PT boats offensive capability that matched their tactical mobility. In death, the innovation outlived its creators. The men who welded the first crude mount, who fired the first rounds in anger, who documented the results that changed naval warfare, they are gone, but the lesson remains. Sometimes the prophet is dismissed, the innovator is questioned, and the warrior who sees clearly must act without permission. The lesson isn't necessarily that every field modification should be approved. The lesson is that tactical threats should be confronted with available resources rather than perfect solutions that arrive too late. That institutional constraints should inform but not determine combat innovation. And that sailors who solve problems should be heard even when their solutions violate doctrine. This lesson was learned at the cost of American lives saved and Japanese supply lines destroyed. It may need to be learned again.